All right, welcome back again. So today's a bit of a long one with this video, largely because there's a bit of math and some understanding on how we can add mouse look. So this is a very common request I get for in game design, and right now it totally makes sense because at the moment, our camera is kind of fixed and we're not really able to look around our environment. So our maze is going to work just great as long as we're moving sideways or forward. But if I have to move back, I can't actually see around where I'm heading. So mouse look is the ability to essentially use your mouse to look around the world in a 3D space. And making this work is not actually that challenging. It's just a few lines of code, but uh, there's some other things that are going to get broken in doing so, which we need to fix. So let's first of all look at just how we can add the mouse look. And the mouse look is going to be done by the player because the player has the camera on it and we control the player. So let's open up our player scene here and get into the script. Well, actually, before we do that, let's adjust our camera a little bit because I'm going to get control of the camera, at least on a side to side. I'm going to kind of go for a more, um, let's go a little closer, up a little bit, more of a like an over the shoulder kind of preview there. So I'm going to start with that and see if I need to adjust it afterwards. But let's have a look at how we can set this up out of the preview here. So one of the really nice things about this setup as the player with a scene and the camera following the player is as the player moves, the camera follows the player. But also, if we want to think about it, if the grab my rotation here, if the player rotates, the camera is going to rotate as well. So it's really just a matter of being able to rotate this player um, and we're going to be able to get kind of a mouse look feel for that. So let's add this feature. Now I could do this in some keyboard controls and I could have a look around with the keyboard pressing, but probably if you've ever played a first person game, you're used to using the mouse to look around. And for this particular game, I'm only going to look side to side. I don't really need to look up too much for my game, but you could certainly add that feature later on. Um, and to do this, I need to grab the mouse movement. Uh, so I'm going to add a new function here. We have a function called unhandled underscore unhandled input event. So essentially, this is any kind of input that's coming in for Godot. This would include keyboard keys and things like that, but we've set that up in our keyboard mapping. So this is just grabbing anything. So it could be a joystick, it could be a keyboard event, it could be the mouse. It's anytime Godot is getting some kind of input. Uh, so I'm going to use that function here to grab it. And what I want to know is if that input, or in fact this event, because that's what gets passed to this function, essentially input or events when things happen get sent here, and this is a function that's grabbing all of them. So I want to ask if that event is a mouse motion, and we have that's already defined for us by Godot. It's input event, and you can see there's a whole bunch of predetermined ones here. And if I just scroll down here, you've got mouse button, you've got um, mouse motion. There we go. If the event was a mouse movement. Well, if that event that came in was mouse movement, then I want to do some spinning. I want to rotate that around here. And we've already done rotation on the rolling with the rotate X, but in this case, I want to look side to side. So just so we can be clear about what's happening, if we look in my 3D world, I'm going to rotate around the Y axis, right? I'm going to spin this way. So I'm going to say my rotation dot y, slightly different way that we did before, but essentially you're changing a property of rotation, is equal to, well, I'm going to be already rotated at some point, and then I'm going to move my mouse and I'm going to rotate some more. So I need to track what the rotation is. So I'm going to say that the rotation.y is equal to whatever rotation.y currently is. Could be 0, could be 90 degrees, could be whatever. And I'm going to try a minus here. You can, depending on which way if you want to reverse your look, but I think minus is what I'm going for. I want to know how much I've moved that mouse. And the movement is being stored in a variable called event. So I want to say event dot, and I want to know the side-to-side movement of the mouse, which is actually an x, right? Y would be if I'm moving up and down. I want to know the event.x. But unfortunately, that's just going to tell me a number. I don't know how much it's moved, or if it's moved a little bit or a lot. So luckily, Godot gives us this relative.x. So essentially, how much has the mouse moved from its starting point? So it's that relative motion. And if we give this a go, let's see. I'm changing my rotation to be whatever my rotation is minus how much the mouse has moved. And if I switch to player level 1 here, let's play that scene and see what we get. Whoa, okay, I'm making very small movements, and in fact, it looks like I'm spinning, but I'm spinning a whole lot. Um, but if I go quickly, you can kind of see, yeah, that's kind of working, and um, but a little bit too vigorous, if you will. And here's the reason for that. This relative mouse movement is basically how many pixels I've moved the mouse. So if I start here and I move here, that's 10 pixels. If I start here and move there, that's several hundred pixels. You can see pixel measurements in your, well, if we switch to a 2D map, you can see there's a kind of a number up there. We start at 0. So if I moved that much, I've moved 100 pixels um, on my screen, which if we look at our player code here, which if I think about that, I'm rotating that number. And we know that the rotation previously is in radians. So 100 radians is a lot of spin. Now, we could try and figure out exactly how many degrees we wanted to change here, but what I prefer is to add another constant up here. I'll call it mouse sensitivity. I'm going to make that equal to, and I'm just going to make it a fraction. So I can kind of play around, and you could even later on allow the user sensitivity, the user to adjust this. So I'm going to say, well, that's 0.01. Let's just make a tiny fraction here. So my mouse movement is going to be how many pixels I've moved times mouse sensitivity. And really all I'm doing there is just kind of decreasing how fast I move around, and I can play with that fractional number. There we go. We've got a much nicer look around here, and you said you could play around with that number as you see fit. There we go. And if we were to play my game, I can now look around the world and I get to, first of all, see that beautiful 3D panorama in the background. It looks very cool and very realistic. But I can also see all of my game now. And I can kind of figure out where I want it to go. So you'll find, I mean, right away you'd say that's great. There is going to be some problems though, because now if you were playing this or following along, my movement is totally screwed up. Um, I can look around great, but let's play that again. If I move just this way, I can move up, down, left, and right. That's perfectly fine. I'm going to get to an open space here. But if I turn and now I press forward, thinking I'm going to move towards the green block, I actually move sideways. And if I move completely backwards, look around the other way, when I press forwards, I move backwards, and when I press backwards, I move forwards, and left and right is all messed up as well. So my mouse look is great. However, my movement is now completely random unless I'm looking exactly the way that I started looking. So that's a problem. And here's why. Uh, well, I've switched to my player here, and I'm going to go look at this from a top-down view. So at the moment, my movement is when I press forward, I am changing the Z movement. And when I press side to side, I am changing the X movement. Well, the issue being is when I rotate my player, say 90 degrees, you can see that Z and X have not changed at all. They are still, Z is still this direction and X is still this direction. So when I press forward, I am still moving in the Z direction, but I move from my perspective, because I'm looking now this way, you can see the camera is pointing that direction. I'm now moving side to side, which from the camera's point of view. So this rotation has caused a lot of problems. And if I were to say move, even looking at a 45-degree angle, I'm going to be very disoriented. And the solution is, well, I want to move in the direction that I am currently facing. So the movement, in fact, has got to change a little bit. If I am looking at a 45-degree angle from my original one, my movement actually needs to be this direction. So it needs to actually be a little bit in the X and a little bit in the Y, a little bit in the X, a little bit in the Y. So I need to change my movement here a little bit. And we could calculate this out. We could do a lot of math to figure it out. If we think about our going back to our grade 10 math here, let's say I've got some X and a Y here. I know it's a Y and a Z, but we'll figure that out. Normally my movement would be that way, and my other movement would be that way, and other movement would be along here, which is perfectly fine. But let's say I am moving, I'm now looking in this direction here at a 45-degree angle. Well, my movement now has to be some X movement and some Y movement in order to create this kind of smooth vector here. And I have turned at some angle, let's call that angle theta. I don't know if you're still using that in your math class, but I know how much movement this is. And because this is my actual speed, my move speed, well, let's call that move speed. So if I want to know how the x component of the move speed and the new y component of the move speed, that is a little bit of your trigonometry, right? This is your opposite over adjacent. Or if I wanted to know the opposite and I know the hypotenuse, then I could say that uh, from your SOHCAHTOA days, if you're still doing that there, that the opposite over the hypotenuse, so the sine of the angle I have just turned is equal to the opposite, that would be my y, over the hypotenuse, which is my move speed. Like so, I could solve for y and I could figure out how much I would need to move in that y, or in fact the z direction, And then I could also figure out using the cosine how much to move in there. And I could do a ton of math in order to make this work. Um, and you could definitely build your 3D engine from scratch with that. But as you may expect, Godot has figured out some of these things for you. A little bit of doing a little bit of the trigonometry in the background and giving you some numbers to figure out how much I need to adjust my x and how much I need to adjust my y, or my z in this case. So we can find this. Actually, we can see it here in play. If I can move to my top view here, um, I can switch to what's called the local space. And when I rotate this, you can now see that the whole thing, the X and the Y, is rotating as well. And over here, I'm going to switch to what's called the basis. Um, you can see as I rotate, here's my original position. And this thing we call the basis is kind of doing that math for us. Right now, looks like I'm rotated a little bit there back. Right now, my X is my X, my Y is my Y, and my Z is my Z. If I were to move in these different directions, that would be each one is how it should be. When I start to rotate around this axis, you can see that my X is got a bit of a fraction here, and my Z is now got a bit of a fraction in the X direction. So that basically I said if I'm moving, I need to move 0.678. If I previously moved 1 in the X direction, I would move to my left or my right. I would not move any way here. But if I'm rotating, if I want to get the same kind of movement, now that I've rotated, I would need to move 0.8 in the X direction and 0.51 in the Z direction to give me the same kind of forward motion based how I've rotated. And you can see if I've gone way over to the side here, that now if I wanted to move in the same X direction in this way, now that I've rotated, I'm actually moving 100% in the Z direction because I've turned myself completely around. Now, the math behind this is pretty complicated, so honestly, you don't need to necessarily really be able to use it. Just understand that this basis number is taking care of some of that trigonometry for you, figuring out the sine and the cosine and how much you've rotated and how much that now needs to move in the different directions to give us the same kind of forward movement. So that's where this basis comes in here. And if I want to, I can apply this now to my programming using this idea of basis. So at the moment, let's see, let's go, I'll use the up here. The velocity, the up motion is giving me all Z velocity. Velocity dot Z is equal to negative move speed. And what I want to do is to change that to say, I want the Z movement to have an X component as well. So instead of just having the Z movement, we'll also say velocity dot X is also equal to negative move speed. Like so. But of course, this is now going to move, I'm going to move in the X and the Z direction at the same time, but it's not necessarily based on how much I've turned it all. So um, if I haven't turned it all, that basis will be 0. But if I have turned, there's going to be a little bit of a fraction. So my Z movement is going to be negative move speed times some fraction here. And the fraction is based on that basis we said. So it's global transform. That's how we are activating that. It's how much I've turned or changed or transformed it on the whole, on overall. I want to go get the basis number. And previously, let's see, when I moved up and down, it was all based on the Z. So I'm going to go grab it, the period Z. And in this case, this is actually three numbers. This is this global transform.basis.z is a vector 3, and I would like the Z component from that one. It's a little bit ugly as far as code, but that's how we're going to go grab that. So this is a fraction, and if you want to see that again, this is the global transform is how much I've transformed it. I'm going to go into this basis section, and I want the ZZ. At the moment, it is 1 because I haven't turned it at all. But if I turn this in some angle, you can see this ZZ becomes a fraction. So it's no longer 1, it's now a bit in the Z direction. And we're also going to use a bit in the X direction here. So I'm grabbing this whole line here. And you can see when I'm almost at a 45 degree, that this is about even. There's going to be a fraction in one direction and a fraction in the other direction. So back to my code. So the X direction is going to be very similar, times global transform. Go get the basis, that fractional number. It's still the Z because it's what was the Z. Movement at all. I'm going to grab that line, but in this case, I'm changing the X velocity. So I need to grab the X component from that ZX we were looking at. All right, let's give it a try. So now instead of just moving in one direction, the Z direction, I'm moving a little bit Z and a little bit X, and I'm using some fancy trigonometry that it's doing for me to figure that out. And let's see if my level 1 now moves a little bit better. Let's see here. Oh, yeah, there we go. I am now able to move kind of in the direction that I'm looking. Or maybe not. What have we messed up here? Oh, yes. And so we had something that we fixed earlier on for our movement, which was to separate these two if then else and elif statements from our forward motion, sorry, our forward backward motion and our left to right motion. So we separated those so that it moved smoother, but now we have a bit of a problem. If I'm not pressing up or down, sorry, if I'm not pressing left or right, then I've set my velocity.x to equal 0. But in fact, I want my velocity.x to have some movement. In fact, every forward, backward, left, and right is always going to have both an X and a Z component to it, which we didn't have before. So we can make a little correction here. These now have to be grouped back together to smooth out our movement, which we just undid, but that's okay. So I'm going to grab this velocity.z and I'm going to cut it and put it down here. And then I'm going to take this line and bring it back together. So now I have an if, elif, 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 else statement. So all four of my movements, left, right, up, and down, are all kind of chained together because they now all have a X and a Z component depending on if I've rotated my view or not. And only if I'm not pressing any of these do I stop moving in the X and Z direction. So if we now play that, I can now, there we go. Now I can move forward and I'm always looking in the direction that I'm moving. Sorry, moving in the direction that I am looking. Now, it only works for forward motion at the time. Right now, you can see my back side, left and right, are still screwed up, but that just involves going on and kind of using some of the code ideas that we took advantage of here to do it the other way. So let's grab my down and make sure that that works. Now I'm going to steal these two lines of code because down is just opposite of up. You'll notice we've got a negative move speed and a positive move speed. So I'm going to replace my movement here and then just make sure that I am going positive and positive. And now I should be able to move forward and backwards. The same idea applies to my left and right, but there's a one other tweak we have to use here. So I'm gonna copy my, let's see, I'm gonna copy my positive one here. And here's my positive move speed, which is to the right. So I'm going to paste that because, again, I'm moving in the X and Z direction. But this time I'm doing it based on how much I've rotated, not based on the Z basis, but based on the X basis. Previously, I was moving left and right with X. You can see that right here, my velocity.x. So I've got to take the Z, the first Z, and change that to an X, and the second Z and change that to an X. I'm still grabbing the X component for the X movement and the Z component for the Z movement, but my basis is a different basis. Hopefully that makes sense to you. Now for my left movement, and if it doesn't, I'll just copy and paste there. Again, now we're using the, instead of negative, positive move speed, we're going to go negative move speed there. And if we play, now I can move forward and backwards, left and right, regardless of the direction I'm facing. I am now always moving correctly, even left and right. I can strafe properly. It's all the math is being done for me, and this code, which I will eventually post up on Moodle, you can grab so you don't have to keep playing through the video, will all be there for you. So great, we've got a movement, we've got a mouse look around, that's kind of wonderful. We can kind of see the edge of the world. It's great to be able to look around and have a wonderful view. You'll notice there's probably one little problem which we need to fix, or two problems we actually need to fix. When I'm looking around, if I hit the edge of my screen, I stop looking, which can run into a bit of problems when we're playing our game. And part of the reason is I've left my game. I've left the window, so the mouse event is not being triggered. I'm in a completely different program from this, and so we can fix that in another nice little way here. So let's close my game. And the issue is my mouse, as I said, goes off the screen, so I want to kind of keep my mouse on the screen. All right, so what we're going to do is get rid of that I am ready on my print statement here. And I'm going to change what's called the mouse mode. So I'm going to say input dot set mouse mode. And that's going to equal the what we call, there's several different mouse modes options. We got the captured, confined, hidden, and visible. So you can hide your mouse if you wanted. You can confine it to the screen. I actually don't need to see it. So I'm going to say input mouse mode captured, which will hide it and keep it at the center of the screen for me. And that's it. Now, if we play our game, you will see now we've lost our mouse cursor, but I can keep spinning around in one direction all I like, and that is going to be fabulous. We only run into one problem now that we've done this. It means I can keep looking around and play my game forever and ever, but now I can't quit my game. Because you've lost your mouse. The game has taken control